Hello, this is Solving and Compound Inequalities, Video 1 for the section on solving compound inequalities. The example says, and means intersection, and when you see the graph on the number line, you'll understand what intersection is referencing. So it says, solve the compound inequality, graph solutions on a number line. A, 4 is less than or equal to x plus 2, which is less than or equal to 8. Compound inequalities will have either two separate equations with inequalities, or in this case, it will be one long equation, but the inequality will happen twice. This time around, it's not necessarily a what you do to one side you must do to another. It's literally whatever you do, you must do throughout. So if we wanted to solve for x, the first thing that we would want to do is subtract the 2. So this one is a one-step question because x only has the 2 attached. So when you subtract 2, you have to subtract 2 from everything. So from all three portions of this compound inequality. So 4 minus 2 is less than or equal to x, because these 2 cancels out, and then is less than or equal to 8 minus 2, which is 6. Now we have what's called a compound inequality. To graph it on a number line, you first draw your number line. Now, I purposely put the 0 on the far left because we're going from 2 to 6. So it says 2 is less than or equal to x, and less than or equal to would mean a closed dot at 2, and then it's another closed dot at 6. Because the inequalities encase, if you will, the x, you're actually going to graph in between. Okay? And as you can tell, it's literally an intersection. It's a portion of a number line, and it's a bunch of different solutions, and there's no arrows in this. So it's an intersection of all possible options. Okay, so for B, you have negative 5 is less than or equal to 2x plus 3 is less than 9. So again, the steps remain the same. Whatever you need to do to the 2x plus 3 to cancel everything out, you're going to do to all three portions of this inequality. So again, 2x plus 3. Plus 3 was the last thing I said, so it's the first thing I'm going to remove. And again, always remember, you have to do the minus 3 throughout the entire thing. That gives us negative 8 is less than or equal to 2x is less than 6. Now divide by 2. And again, I did it to all three portions. You get negative 4 is less than or equal to x is less than 6. Now, let's say that you're still not understanding why the number line looks the way it does. Well, you can take this inequality and split it up into two inequalities to see the visual. We have x is less than 6, that's this portion here, and then we also have this portion, which would be x is greater than or equal to negative 4. So if we wanted to graph this on a number line, I'll not be able to go to 1 if I do that. Make it longer. Okay. So again, so it says x is less than 6. So at 6, you would put an open dot. I'm actually going to go ahead and change the color real fast. So again, at 6, you would put an open dot, and less than would be pointing to the left. Now, x is greater than or equal to negative 4, it means you're going to put a closed dot at negative 4, and your graph would be pointing to the right. Well, these graphs don't cross each other. Once it hits that negative 4, it has to stop, and then once it hits the 6, it has to stop. Because it's not 7 and it's not negative 5, those aren't options. So it's everything in between the two numbers that are provided. Now in this case, it includes negative 4, but it does not include 6. So here are the two U-tries. Solve the compound inequality, graph the solutions on a number line. A is negative 9 is less than x minus 10, is less than negative 5, and then b is negative 4 is less than or equal to 3n plus 5 is less than 11. Please remember to write all these out and make sure that they're done before class, as from here on out I will be posting solutions. Alright, and that is the end of the very first of 3 videos.